Okay, I think... Yeah, okay. That's quite distant, actually, so we're not going to listen to that. I probably can't listen to local natives because that's going to get caught. So let me like shuffle my library once or twice. Find some music. Boom, boom, boom. You know what? I'm just going to go find my playlist because I'm sure I've got one somewhere that's actually good. Yeah, I'll just do the actually Violina because Violina is always good. Is that even visible? It's probably not visible. It probably shows up as nothing because I'm not watching. Um, okay. Well, it's recording at the same time too. I don't think I've ever had to do that. Well, in any case, hello to the people now watching this. Per the title of the stream, I have some 4x4 by quarter wall tube, rounded edge, not the fancy aluminum rectangular edge stuff that's extruded. Probably run in a mill. It's clearly got a weld on the inside of it. And these tubes make up part of a car lift that my dad's got, and the issue is they poke out in such a way that makes it really easy to sort of like jab yourself in the face with them. And because I am 6'5" and my dad is 6'1", my brother is 6'3", and the lift doesn't go quite high enough to get that out of the way of our face, it could be, you know, very, very sufficient head bumping territory. I'm also realizing this is aimed down a little bit. That's fine. It doesn't make much difference. But, so, first thing I'll need to do is come up with a... Oh, hey, viewers. Hi, viewers. Can I see who that is? No, it just says participants. There's nobody. Okay. I need to go... Or no, that's not. That's not the design library. That's the folders. I'm working over here at the moment. The idea basically will be construct a reference body for me to work around. I have reference dimensions that I've already pulled. Book. Not notebook, bookboard. With some sort of extant dimensions that I'll need to think about. Mostly stuff like outer dimensions. That's a really terrible drawing, but sort of the critical features. Like there's a tube in the middle that I have to care about. I forgot to record how far back it is, but it's enough to know that I need to stay clear of it. I'll just guess like 3/4 of an inch and that'll be fine. Plus the weld bead that I have to think about and take care of, or rather make sure that I don't hit. So let's get that squared away. And oh goodness, do I not actually have... Oh, phooey. Okay, I guess I don't have the features that I thought I had, so we'll have to sketch some things manually. Start with just a simple box. Oops. I'm gonna do these extra lines here so that I can align it. Make this one vertical, this one horizontal, and make them the same length. Then I get squareness by default. And I know that this is, it's a little less than 4 inch on the major dimensions. So, oh, I'm working in millimeters. Hang on. Let's make that 4 inches. Millimeters happen to be more convenient to work in most of the time, especially when working on 3D printing projects. So let's include the sketches or the fillets in here because these are close enough to being part of the profile that I'm willing to put them here. We'll say, what did I record for that? Probably I think I recorded 0.50, so we'll start with that and we can always tweak it later. Magic of parametric modeling. Say okay, looks just fine. Offset entities. I was working with a 0.248, not 248, but 0.248. If I could type things correctly. Looks good. Features. Let's make this, put our origin on the front face just for ease of locating things. Oh, hi Dad. I didn't notice the message because it was down at the bottom and I can't read. But we'll make this, say, 5 inches long. Let's do 6, just give ourselves some clearance. And then we'll work over in the top plane add this piece of pipe here in the middle is what holds the individual posts that interface with the car frame, because you can't just have the legs themselves interact. You want them to be a little bit free. I'll make this, we should make this pretty close actually. Let's make it 1/2 inch on the face. And I'll pick these 2 points and make them vertical so that it doesn't move around. And now I can do some up to next extrusions, so I don't have to think about how long they have to be. And then that'll give me a body that I know I have to stay clear of inside that volume. The last thing to add is the weld bead, which I need to add on the left side. So we'll do that with just a straight up extrude here. And add some extra bits over there and all the other fun stuff. Adding this line just so that I can control the vertical position, and that I know it'll be on the center line, because it was on the real part, and that's good enough for me. So this was only a 1/16 of an inch thick and only a 1/4 of an inch wide, roughly at the worst case. So we'll just do extruded boss and then up to surface, and I'll pick this back surface. The other way you can do that is using the dimension on this feature, D1 at boss extrude over down here. You can make this, oh, I forgot because I didn't do it blind, I did it as an up to surface. If I do blind, I can do equals D1 at boss extrude 1. And now, even if the feature itself changes, or some part of the profile changes, and it changes the internal identification of that back face, that doesn't get in the way of it doesn't get in the way of making that particular extrusion long enough. I could probably also do it in the same profile, but whatever, it's not that important. So let's add some extra chamfers now. If I pick this face, it'll pick, let's see, 0.0625, because those were probably, well, let's do 0.125, because they were big-ish welds. Let's flip the, you know what, that's close enough. I don't have to think about it that much. So this is roughly the environment I'm working in. Now I need to place a cap in here, and I haven't really thought extensively about how I want to do that yet, but what I can do is, from the start, make this guy transparent, so that I don't have to, I could just sort of imagine it as a separate body. It won't be one that I'm merging to, it won't be one that I'm using to subtract things from. It'll just be its own deal. So let's start with a front plane sketch. I'm going to grab this front face and do convert entities, so I have the profile I'm working with. I kind of want it to have like a little bit of interfacing end. So I'll click turn off merge results so it doesn't do anything extra. And then I'll have just this extra body so that I have a nice sort of, a nice bit that matches the profile of the rest of the pipe at the end. Next up, I'll do the same thing, convert entities. Not always a safe way to do things. It's probably safer to convert always from one sketch, but I've got enough of an idea of how I want to draw this that's okay. So take a wild guess, let's say 3/4 of an inch of standoff, and then add some draft, say make it 50 degrees inward. And that's not half bad for a quick start. So let's now add a quick fillet around the top side and say 1/2 inch. And what does that look like? Not bad. Maybe I want a little larger radius, so let's see if I can't do more. How big can I get? 0.75 gets it pretty close to that, but I bet if I steepen this up a little bit, say 30 degrees, I can make this up to maybe 1 or even 2 inches without too much. Oop, no, 2 inches has gone too close. Back that off to 1.5. Sort of eating the whole structure now, aren't I? Let's undo that somewhat. Bump this extrusion up to 1 inch. Give myself some more room to play with. Yeah. That seems roughly correct for something that's ideally trying to not bump your head when you run your head into it. So Dad, feel free to provide feedback if you think that's not really, or you want something a little more, having brain fart, something a little more rounded, because these look like they kind of come to sort of sharp edges. Actually, let's see what the curvature tool tells us. Oh, curvature gets bigger, actually. No, is red? No, red is smaller curvature. It says 7, but over here it says... Oh, radius of curvature. Yeah, the radius of curvature is getting smaller. Okay. But, broadly speaking, that's a pretty large surface, and I would hope fairly friendly to heads, is the idea anyway. Oh, I should save this and do this off screen. Need to make a new folder. 22032 for Jerry Shaper and 4x4 by 0.25 bumper. We'll just call this bumper solid part. That's fine. Head can skid off rather than cut. Yeah, that's the idea. I might even actually... Maybe I want to leave this a little steeper to that end. Like, not do so much with the radius, but do more with the... Because if we look at it from the side over here, this is the surface roughly where it'll contact. I don't remember where my eye level meets it. I want to say it's about here, but this seems reasonable to be a deflecting surface. Yeah, that seems okay. So now that we've got our sort of main body, we'll switch to doing the... I need to have... Let's see, let's do this with a section view as well. Oh, I should... Hang on. I'm going to adjust this cut through the middle here and add... Oop, not a mirror. Just want to add a circle. I'm going to make a wild guess as to the ID of this pipe. Say it's probably 2.1-ish inches, since that would let you have a nice big 2-inch boss in the bottom of your interfacing. I should show what this looks like, actually. Hang on. Car lift pad. This is roughly what we're dealing with. So these sort of telescoping pads. I mean, these ones are telescoping, so I think they adjust height. But I've already got I've got numbers on the main pipe, and I have numbers on the OD of this. I just wanted to like show what I was working with roughly. And 2 inches seems about right. It's close enough to the thickness of the other walls of the associated elements, so I'm happy with it. And mostly I just want something so that when I come up here to the top view, and I'm going to turn that not transparent. Oh, I can't change appearances in section view. You know what, let's make this guy yellow, because that's what color the part is in real life. Bright yellow, or even a duller yellow. That seems fine. Yeah, okay. So now what I want to do is I want to merge with this face. I want to come up with some sort of ears that pierce in there, and then I'm going to split them after the fact so that it's going to be hard to explain. I think as I do it, it'll make more sense. So let's do a sketch on the top plane and say I've got these, oops. I don't want those to be too thick, probably 1/4 inch maximum. 0.25, or that's not 1/4 inch. And I want probably at least, let's do 0.1875. I want them maybe 1.5 inches long, seems about right. And then I can come back here and I can select this line in this face and say collinear. And now I have it exactly positioned where I want it to be to line things up. And adding this construction line here and selecting the whole volume by just clicking inside of it, or the whole profile rather, a quick right click and drag to the mirror just makes it right up for me. I'm also noticing that this internal fillet seems too small, like maybe I left the thickness of the part too much. Oh, no, it's 0.248, 0.50. Is that, yeah, 0.252, so that's seems about right. Um, anyway, back to this sketch. I'll pick this guy and make it coplanar with the inside there. Oh, that's not coplanar. Why is that? Oh, I forgot because the weld. Okay, so I will make that collinear. And I'll make it, hold on, where's calipers? Usually keep some calipers around here just so I can get a quick estimation of sizes. Yeah, make them an inch thick. That's about right. Features, extruded mid-plane so that they're all lined up. 0.25. Yeah, that looks about right. About 1.25 inches high. Merge result, but I have to change from all bodies or from selected bodies and auto select to selected bodies and just the one that I care about. And now I can come back here and hide this. And this is one body, and this guy is one body. And they're both separate. So now I need... Well, I want some clearance to things. So perhaps what I'll do first is I'll do a move face. I really like to use move faces for printed tolerances because it's just an easy way to say, yep, I want this much, I want exactly this much sort of clearance tolerance on things. And it's always good to zoom in and double check and make sure that it's going the right direction. Like try suppress and unsuppressed, and you can see this face move back and forth. It also preserves IDs, which is super handy when you're doing direct modeling screwy things. And doing it before I make cutouts for the weld is good, because now I can come back to the front plane and say sketch, show the part again, make it transparent, and I'll do it, well, let's do it from the back. Let's do it as, I'm probably going to do this on both sides, because there's not really a reason not to, and it lowers my, it'll lower the stiffness of the system a little bit, which will help in making sure that things fit together nicely. So now we come back and say, let's see, let's do this guy on, oops, I can't hide that face. Select other then. Shoot. Oh, I guess it was. Oh, there we go. Okay, now I have the right face. And now I can say collinear. And I might even show this sketch actually. Because that way I can make this concentric and give myself sort of a defined clearance between the two. Say 1/8 of an inch is probably plenty. Now we'll do a quick add a line there, select it all, mirror it, extruded cut, and let's do up to next. And only for this body, because I don't want it to also cut extra bits that I might not want. Oh, could not find end face. The hell? You could find an end face. Alright, guess you can. Up to... have to do a select other again to grab this end face here. Lots of weird colors going on. Up to surface. Oh, that's just picks the direction, doesn't pick the face. It's more... This is interesting. I don't remember having all these extra fields to select here. Maybe that's something just in 2021. I haven't done a lot of modeling on my own lately. It's mostly been at work. So select other so that I can pick the face I want. Say OK. Ooh, that cuts a lot of material out. Maybe I don't want that. Maybe I want it to be a little bit less. I come back here and say only a 1/16 of an inch. That seems more reasonable. How are we looking up top too? Let's hide this guy for a sec. I definitely want these to have more springiness in them. I think what I'll do is I'll do sort of a, let's do a sort of a 2 circles cutout kind of deal. I'm going to do this as a separate op as well because I want it to be controlled separately. So, oop, I'm still showing a sketch somewhere. Which sketch is this? Oh, let's do Control T. Is it Control T? Why is it not switching around? Here we go. This is the one that's shown. Normally, I think Control T will show you your tree sort of unfolded. Tree display. Don't remember. That's weird. Usually there's another thing that will let you show it as a continuous stream of features in their true order rather than sketches being folded in under things. But that's not especially important. Let's just do this for now. So I want 2 sort of circular cross sections. I want them to be tangent. I want this guy to be on this line so that I know we're tangent down here. And say, what do I want this minimum width to be? Probably 1/8 of an inch. Somewhere around reasonable. Make sure these two are tangent. Select a maximum length for this cutout of maybe 1 inch. Come up with some... Actually, I like to do this by exit angle just because it's kind of fancy. I'll add an extra line over here. Tell it to be tangent to this. And then I can control... Make that 45. That's too tall, for example. Put down to 20. Seems about reasonable. Maybe a little steeper than that. 25, maybe even 30 degrees. Yeah, and that gives me a nice concentrated point where I get lots of flex. And then I can use that later when I want to control, or when I'm adding features to another. Whoops. Come on, let me mirror. Why is it not letting me mirror? Select chain, select that, mirror. Okay, it worked that time. Guess it doesn't like doing Control A. Oh, it's because I had this extra line up here. If you have more than one construction line selected when you use a mirror command, it won't automatically pick one. So we'll just do it through all both. There's our cutouts. That looks really big, doesn't it? Let's shrink it down a little more. Just divide by 2 in there. Just add a /2 and then it'll just straight divide it. Let's unhide that and take a quick peek at... You can even run interference detection, I think. Yeah, interference detection. Calculate no interferences. If we treat coincidence as interference, it'll show us that we have one interface here, which is what we want. That's where we want to be mating against. But besides that, it'll be working pretty okay. So I haven't thought yet. Actually, it just occurs to me that I haven't thought about where I want or how I want to make sure to control the vertical position. So I'll do that with some extra little bump outs near the end, I think. And now let's go back to hiding that again and add, let's see, on, is there an easy way for me to pick right feature and left feature? Yeah, there we go. We'll set this pretty small because we don't want these fillets too big. And I always like to add a round corners if I can. Unless it breaks things, which it seems that it does. Keep edge. Yeah, round corners breaks things. Huh. Weird. It's probably something to do with the fact that these are at a different height. Like, this angle is slightly different from this angle. And you can tell that if we do a deviation analysis along these 3 lines. Crank that way up because it doesn't take that long to calculate. Average deviation 84.6. We can even take these 2 out and calculate. Oh, never mind. It's not precise enough. Anyway, the crux is that this deviation is that it changes through here and that'll break round corners. So if I left myself a straight section, then it'd be fine, but it's not that crucial. Not that worried about it. I'm also realizing that if I do that, then I can't actually have that fillet there. So I need to get rid of these 2 fillets anyway. Because what I want to do is basically cut this section and this middle section out so that I can have a... How do I explain this? I can have this piece as a separate chunk that sort of separates out. And I think now's probably actually a good time to do that. So we'll do a top plane sketch and just do, let's see, how do I want to do this? Let's add, doing some thinking about how thick I want this to be. Say 1/2 inch is probably fine. maybe make this bridge section 1.5 inches. Well, 2 inches seems fine. And now we're going to do this as a extruded surface with midplane. Or actually, I have to do it as 2 up to surfaces. My bad. 2 up to surfaces. And then I can transparent this guy and do planar surface. Bounding entities. Okay. So it won't let me do that in a nice way. It's a little different. Let's clear this out. And let's do something like this, where I capture the whole section that I want to split, mirror that, add this dimension in here, 2 inches, this dimension in here, 1/2 inch, make that coincident with that so it's symmetrical. And let's do sketch, exit sketch, and change the properties of this extruded sketch so that I cap both ends of it. And now, if I use it as a split, trim tools, whoops. Maybe it's an intersect? Let's try an intersect first. That's a more expensive operation, but consume surfaces. I want to make sure that I'm not merging result. I don't care about that section, but when I say OK, I should be left with a transparent. There we go. That's what I want. It's 2 pieces now. Let me do this with a quick move. Can I move body? Yeah, I can move bodies. This one, and we'll pop it out along the z-axis, 3 inches or so. Unhide this guy. Turn off transparencies. So basically, this cap goes on, then this cap will slot into place over it, holding it in place. That's the idea. There are not welds on both sides of the tube. I guess I don't really need it to be symmetrical, but I think there's only welds on one side, but if there are welds on both sides, then I forgot to start music, didn't I? Whoops. Let's start music. Just kidding. Is that quiet-ish? Yeah, I'll turn that down just a hair. Okay, I have music now. I forgot. Whoops. Anyway, okay, there's not welds on the insides of the tube. I'll probably want to switch this to a fillet, just so that it gets nice and just so that it's like a nice interior feature, then it's not going to break anything at all. But let's get rid of that body move copy for now. Hide that again. Where do I want my clearance faces to be? I think I want my clearance faces to be on these faces. So what I'm going to do, first I need to come back here and make sure that this is fully defined. Make these two equal, make this, say, 2 inches. Make this 3 inches, just that it's all fully defined. Now, I'll go back here and add some corners so that things are nice and smooth. Then hide this guy for a sec and say, I would like 0.4 millimeters of clearance. So one track width. And I want anything, it looks like the, yeah, okay, so I can't do internal to feature because it counts internal to feature as everything that was ever touched by the intersect feature, which we can check by going back here and saying, hey, what does the intersect feature show? And you can even see that on both bodies, I think. It's touching everything that was ever used to interface, so don't really want that. Instead, the easier way to select everything is going to be with probably an adjacency or all surrounding? Yeah, all surrounding is the way to do that. It's also going in the wrong direction right now. So flip direction, shift tab to unhide the body, and now we have a little bit of clearance. Should be just barely visible. I might shrink it down to 0.3, but it'll be quite small. Come on. 0.3 millimeters. Gets a little bit smaller. Yeah, that looks good. And I may do some stuff with chamfers and things as well to make those edges extra clear. Let's go back a little bit to the cut extrude. Oops, things are transparent still. Whoops. Fewer transparencies, please. I don't want this little bit here because the odds of there being a little bit of weld that far out, I'm pretty sure there wasn't on the finished part, so I'm just going to delete those. And it occurs to me I should probably name my features so it's easy to figure this out later down the line. We'll call this main square tube extrude. Pipe section extrude. Yes, okay. Reason for doing it into two pieces. My dad's suggestion. So, the issue with this shape, really, is that it's quite hard to print in one orientation. Like, if I want to print it like this, it's going to look like crap right here where it needs support material to get the overhang. But if I print it as two pieces, then I can have this piece printed on this face, and I can have this piece printed on this face, and things just get printed in a nice orientation where you don't have overhangs, you don't have supports. You can, in particular, you can use the extra stiffness you get with bending out of plane that comes from 3D printing basically for free by separating it out this way. And you get cleaner stiffness, cleaner flexural stiffness by bending in plane with this orientation, printing the interfaces this way. So that's the primary motivation for doing that. I've got some clearance. Let's see. Oh, I was naming things. Interfering weld extrude. How I wish it weren't there. Pipe weld, chamfer. This is interface plane extrude. We'll add these to reference body features. This is the primary bump volume extrude. Bump volume fillet. We'll call it A, just because I like to name them with an extra letter for clarity. Interference. I don't want to call them snaps, but we'll call them interference. Interference arm extrude. This is interference arms clearance. This is the weld clearance cut. And this guy is the interference arm flexure cut. What is this to the lead face? Oh, right. Weld clearance cleanup. And interference arm backside fillet. This is the splitting surface extrude. Or split tube, tube body intersect split. It's so much easier to figure out what's going on down the line if you name these things. This is the, we'll call them the bump body and the arm body. So this is the bump body interface clearance. Cool. Okay. Let's do. What needs doing next? Let's add the interference features. So let's do hide that solid bodies, right planes, sketch, and we will add gonna add some lines so I can locate things. Oh, I can send you a printer automatically, can't I? Yeah. It occurs to me that I don't want to do this to the center. What I want to do is to the axial points on this guy. And then I can use these lines made if I use them, if I tell them to be concentric, or rather is it coincident? Yeah, coincident with this center point of the ellipse, then it will, by default, make it located and oriented correctly. Yeah, I can't even rotate the things now, I can only change their shape. So, these are all for construction. And now we pick these four and say Q on all of them, so they're all the same. Say I'd like 0.0625-ish. What do you mean invalid geometry? There we go, that's not invalid geometry at all. Now I have two ovals, which just happens to be my preferred shape for this sort of thing. And I can use them as a split line, I think is the correct way to go about this. Pick these four faces, say A-OK. Quick refresh to get rid of those. It's just a weird graphical artifact that happens sometimes with the sketches. Now, I have four faces that I can apply the dome transformation to, and I can make these, I can configure these to have exactly the interference that I want. Let's do 1 millimeter for now. Stay okay. Looks alright. And now, if I unhide our friend the reference body and say, interference detection, calculate, I can see that I have just a little bit of interference there, which will be perfect. I'll have a little bit of springiness holding the things in place. It also occurs to me right now that we hide these two for a sec. I might have some flex in this section if I don't leave this thick enough. So I'm going to leave that just a little bit thicker. Like that goes from, that was 0.625 and now it's 0.75. Scaling with the fourth power, I think. What's, for a rectangular section, it's like with the third power of height, so 0.75 divided by 0.625. Raise that to the third power. We increased our stiffness by like 70% in this section, which is great because it ensures that we get only deflection down here and not deflection up where it might be visible. Unhide their other bits. What else do I have to think about? Let's add, or I should name these. Interference split line. They're called crush ribs, I think. I'll call it the crush rib split line. I think that's the technical name for this feature is crush rib. Yeah, crush ribs. They're great for 3D printing because you can use them for interference with all sorts of like more actually precise things. But it gives you some ability to tolerate floppiness in your manufacturing process. I'll call these the crush rib domes. So let's go through. This is most of this. Body. We'll call these main body features. It seems fine. I'm gonna go up before. Actually, let's go after the clearance. And then I want to add some specific features. Whoops. Selecting tangency guarantees that you'll pick up every line if some tangency changes down the line. So we'll call that 0.125. That gives you like a nice internal feature that makes it so it's harder to break there later down the line. We'll call this the bump body interface fillet. And if we come back here, do a chamfer, say 0.125 but times 1.5, And I'll use the equal distance chamfer. It tends to behave better for me. I don't know if it's quicker to rebuild or not, but it happens to be my preference. We'll do select tangency on both of these. Looks good, and we'll call this the interference body interface fillet. And probably worth bumping this up a little bit so that we don't have a scroll bar down there. If I, don't want to hide you, I want to hide, or unhide the other guy. Now we have, I'll show it in profile so it's easier to view. I'm guaranteed to only contact on these faces. And I won't have to worry about any problems with edge printing, which is usually where most of your errors crop up. 3D printers can make flat surfaces pretty easily. It's sort of it happens to be one of the handful of things that they're good at. Add these features into the interfacing, two body interfacing features. Drag that down to the end. So now we've got our interfacing domes. Probably worth a quick look at the top plane split. Just very quickly, what's the distance here? Nominally 0.4 millimeters, so I only have 0.6 millimeters of interference. Honestly, it doesn't seem like very much. I think I'm going to bump those. Ooh, here's what I can do. I can make this value equal to... What did I set this? Nope, that's coming from the crush or split line. Main body... Interference arms clearance. So this is D1 at the interference arms clearance, which sounds like an advertisement for firearms. We'll say equals 1 millimeter plus D1 at interference arms clearance. And then I'll always have 1 millimeter of interference. And in fact, I should probably drag that down just a bit to check. Boy, that looks like a lot, actually. Whoops, appearance is going to be changed in section view. Yeah, that looks like quite a bit. I think I will back that down. Come in here and say 0.6 probably is fine, but this way it makes it parametric to how much offset I give the arm by default, which will make sure that we clear any burrs or any painting stuff that happened. Okay, let's take some wholesale stock of rebuild and save. Yes, vertical alignment features. I can't do that in this nominal print orientation, can I? Because I can't add features back here unless I screw up. Shit. I guess I don't see any reason why I couldn't add another sort of vertical orientation wedge. On the other hand, if I make this taller, which is pretty easy, you just make this like 2.5 inches tall. Then it's not going to have enough room to wiggle, really. Let's throw in a fit. Oh, fillet in here is... Whoops, this is a chamfer. Edge or fillet for chamfer does not exist. Okay, I guess I'll just clear it and it will be happy to not exist. Do you think making those wide enough will work? And I should also see what this is in millimeters. Minimum distance, 3 millimeters. That's at least 8 sections, or 8 traces thick. I think that's probably enough to be sufficiently stiff and to not flop around when it's in there. Based on rule of thumb. I'll only print this section first, just to make sure that the fits are good enough. Let's add a chamfer in there for fancy. And if I make this shorter, how much does that affect it? Oh, that looks alright. Towers off one side that end up going down and can twist through hole. Nope, that doesn't make sense. Alright, let me think about that for a sec. So you... Oh, someone shoot me a message. I don't think so. No, okay. I think I do want to leave these tall. One side of each of the crush fittings. Oh. I got a call from my dad. Hello. Yeah. Yep. Oh, yeah, that makes sense. I'm also hearing myself stream with about 15-second delay, which is... No, it's fine. It's slow enough that it's not throwing me off. But, yeah, that makes sense, actually. Yeah. I think I understand how to make that work. Yeah, okay. Okay, so... these, instead of sliding into place, will sort of pivot into an out, so that you can have a leg here that holds it up, and is still out of the way of everything, which means I need to be more careful about clearing the arm, but I think that's okay. Yeah, okay. Means I have to be a little more clever about how I do... Let's see, how do I... Oh, that's actually so much more fun, though. Yeah. Okay, so I have to walk back to how I'm generating this surface. Yeah, cut out. So basically, a cutout for rotating the thing into place. Yeah. Okay. So I need to come up to the splitting surface. And it does change... Oh, I gotta make sure that it's actually printable. Okay, let's step back a bit. Come to before this. And make that not... Do this. So if I have little legs... Any books to get a noob to a pro? I don't know, really. There's not really a substitute for experience, and I've never read books to get better at SolidWorks. I've just, like, tried to find things that seem like they'd be hard to model, and just trying to experiment and find a feature and figure out how to break it. Because, like, once you understand... I don't have any pictures of them, unfortunately, but I've modeled, like, this little conical spiral. Once you understand how to, like, draw curves and things and how to get SolidWorks to play nice with what you have in your head, the best way to know how to do that is to fight SolidWorks and make it break and, like, understand what causes causes your features to break. That's... Yeah, a third piece that goes inside to hold up the arms. That's probably easier, actually, than trying to figure out... Yeah. Because the way I've modeled the interface arms right now isn't especially conducive to... I mean, it wouldn't be that hard to change, but it's tricky to also add a rotating in element. I can sort of see how I'd do it. It would just be tricky. But I think I could add an extra piece pretty trivially. No, not at all. Hopefully that answers your question. It's like, I don't have any good recommendations for books besides just finding interesting parts or coming up with a shape in your head and trying to figure out how you would draw it in SolidWorks is usually what I find to be the best practice. Because at the end of the day, even if you read the book, you're going to have to be using SolidWorks to use the techniques the book teaches you. And if you can bring yourself seems sort of pessimistic, but if you can find the drive to like just attack strange problems, that's what I find to be personally the best way to direct you into like learning how to use the software better. And I think I am going to do this with a spacer just because that's easiest. So let's do. Oh, a roadmap to certifications. Are there any good ones? The exams or the test exams that SolidWorks themselves supply are quite good at pointing you towards that. I don't recall if there's a good book towards getting CSWP and CSWE. I have a CSWP. It hasn't made me any more money, but it's a feather to keep in your hat. Really, the reading through what the exam says it will test you on, and then just reading through the help documentation for every feature you think you might use, and just sort of beating your head against that wall. That's what I did to get both my CSWP and all of my like associated CSWP add-on for like weldments and sheet metal and all those other fun things. That's just fighting the features and learning what makes them tick and how to make them play nice is usually the best way to get yourself experience for one. And especially for certifications, wherever it is that you're working, the license or whatever reseller your company goes through to get licenses, they probably also offer free certification vouchers. And if you're the only person at your company doing that, I mean, depending on how big your company is, there could be like a good 20 free vouchers lying around for you to take those tests. To date, I have not failed any of mine because I had pretty good instruction and lots of experience before I took them. I think it was probably 4 years working on and off with SolidWorks, first as a formula student participant, and then as an actual mechanical engineering designer. About 4 years, like between starting and being able to take the test, and I was able to take was able to pass my CSWP without almost any issues. So hopefully that helps. Where was I? I was going to do a vertical spacer. We're going to make this pretty simply, actually. Let's do, from the back. I did it on the wrong plane. I want it on the front plane. I'm just going to do this as... Let's do this. Whoops. No, don't do that. I don't want it to accidentally tie to any other features and reference things. Yeah, happy to. Ideally, like, my ultimate goal is for everyone to be happy with their ability to draw things in SolidWorks, and however long that takes, as long as I keep teaching people to do stuff better, that's kind of all I want. So, quick select chain and another select of a construction line and a mirror, and things are all in the right spot. I'm gonna add. Yeah, I'll make those flat with that. Ooh, I should probably do this before. Well, it's gonna come out in roughly the right spot. I'll just make this. I'll make it collinear with that guy. Come up here and say, where's this? Pick this, and where's that surface? I want that one. This doesn't have to be that tall. In fact, I could probably make it pretty narrow, say 1.5 inches. But I don't want those to be 45, which it looks like is what they've done. Oh, no, they haven't. Never mind. Add that body so I can access this face to make it... Well, I don't even really need them to extend that far. They can kind of be... They only really need to come that far out. They don't need to be that tall either. Like, probably 1/4 inch is fine. Features, extruded boss. Let's do... Be pretty thin, probably. Not too thin, though. maybe 1875. And don't merge. Yeah, that seems okay. Quick height of these two. Make these probably as large as a 1/4 inch. Quick peep of top plane cross section. Make sure we're pretty well free in that department. Looks okay. I guess I should think a little bit about how interferencey I want this to be, because I don't want it to be too tight, but it should be fairly tight. I'll probably make it a little bit tighter, maybe only... oh, I haven't named anything for a while, one sec. Push rib split lines. What chamfer is this? Oh, this can go much earlier. Interference arm flexure cut. Oops, why is that? Oh, hang on. I see why. Chamfer is missing 2 edges because they got caught by the interference. That's for the intersect. So call this interference arm end chamfers. And then we've got this guy over here, which is the vertical spacer. And this is the vertical spacer interference arms clearance fillet. That's a bit of a mouthful. Call these the crush rib features. Hang on, why'd they get inverted? How'd that happen? Oh, because it happened before the fillet. Derp. Okay, so what I want actually is for these chamfers to come right after crush rib domes. There we go. Now the crush ribs are the right size. Much better. That was silly. Okay, vertical spacer interference arms clearance fillet. Let's add some clearance in there as well. Not delete face, but merely a move face. And we'll do, let's see, all coplanar and all coplanar. Take a quick peek and say 0.2 millimeters. Flip directions so we know we're away. And unhide everything again. Come back here. Looks okay. Yeah, I think that's alright. So this is the vertical spacer interference arms clearance. That's so much of a mouthful. We'll add a quick like volume saving extruded cut in here as well. Probably 1.25 inches or so in diameter. Whoops, not mirror. Maybe 0.5. Because this vertical spacer doesn't need to have that much mass. All of this internal stuff can be gone. So we'll do, that actually looks okay. Call it an extruded cut. Put a hole in it! Up to next. Do not auto-select body, select merely this body. Rebuild. Everything looks good. Unhide this, and then do another interference detection. Oop, do not treat coincidence as interference. Why is... Why... Hang on. All bodies. Why is it showing only a tiny interference? So there should be more interference. Interference arms. Interference detection. Calculate. Show ignored. Okay, those two interferences. Just do everything. Okay, so that little interference, it's not real. That interference which we expect, these two interferences we expect. Those two interferences which we expect and require. These ones with this vertical spacer, also expected. More, why? Okay, something, it should be interfering more. It's a little worrying it's not. 8.8 millimeters. Okay, another quick interference detection. Do not treat coincidence as interference. Non-interfering bodies, but everything... Vertical spacer. Lightweighting. We'll call it the lightweighting cut. Okay, top plane. Okay, that is definitely. Gotta turn this off and add the transparency back. That's definitely interference. I don't know what universe it's not interference in. Okay. Okay, what is the maximum distance between these two? Maximum distance. I guess it'll only give me the minimum distance. That's kind of annoying. Let's do midpoint. So can I do intersection at this, or a split line at that endpoint? I guess I can't. But I can have it tell me what that distance is, and it's 5761. So if I say go to 0.5761, I know I'll be right at the midpoint of this. Okay, this is silly. Please tell me where my interfaces are. Yeah, that's 20 thou more, which is some amount more than a little ramp to hold the vertical set piece in place. Not be saved in an empty sketch. Whoops, don't want an empty sketch. A little ramp to hold the vertical piece in place. Yeah, I guess there's nothing sort of holding it there, is there? I guess I could make it just a snap fit into place because it'll already have a little bit of... So let's do top plane sketch. Just the tiniest little bump out. We'll even do a convert entities to make sure that I have everything right. Trim that stuff off. Add this bit in here so we can mirror things. Okay, I want this maximum distance to be pretty small, like 0.2 millimeters. It does not need to be big. Well, 0.4 millimeters, just like an extra little bit of bump out. And the maximum distance should be quite small as well, like 0.6 millimeters. It doesn't need to be that tall. Whoops, nope, that's not a radius, or rather I don't want it to be a radius. Make it 0.0625 is probably plenty. And rather than making it dead flush, just because I'm working sort of near the end of the model here and I don't want to use move faces to align things, I'm just going to say be 0.1 millimeters spaced off. Where's my views? Yeah, 0.1 millimeters spaced off. And now we will merge with just this body. Up to surface, pick this one, pick another surface. Go right there. Yeah. Ooh, that looks quite drastic, doesn't it? Instead of having it be the full length, let's make it a little bit smaller. I think that's the reasonable course of action here. really doesn't need to be that long. Point 2 millimeters. Like 4 millimeters, make it a little bit smaller. It really doesn't need to be that big. And that should be just enough to retain it in place, plus press fit silliness should be pretty close. I also made it on nominal, which probably isn't ideal. Probably ought to... Here's what I'll do. Move face. I already know that it's going to be in the right spot, so I'll move it back to, say, 0.4 millimeters. Make sure I flip direction, so it's getting smaller. Go up the top plane. Sketch. We're going to do this with a slot this time. Ugh. These equal so that we have some sort of equal offset going on. Make that millimeter because we're mixing metric and imperial now with wild abandon. Split line on this face and this face. Dome them to the tune of 1 millimeter. Seems okay. Unhide this other body. Take a quick peek at our right cross section. Yep, just a little bit. Probably want to make that a little smaller. We'll add some names for this. Vertical spacer, retention bumps, retention bump extrude, then vertical spacer tube clearance, vertical spacer crush rib profiles, vertical spacer crush rib domes. Extrude. Nope, come on. Features, there we go. Okay. That should be well clear on everything we have to deal with. Probably want to make the dome a little bit smaller. Say 0.8 millimeters, so that it's only interfering a little bit less. Plenty to hold it in space vertically. Ooh, I haven't been doing this. Let's do section by body, include only this guy, and add a second section. That's 0.5761 on the top plane. 0.5761. Oops. Hang on. So I'll pick this zone so it's somewhere nice and viewable. Or actually, if I do 7, then it comes out on the nice side. So let's do intersection zone 1. Okay. So we got interference up here. We got interference up here. That's like a nice slow one. And once you assemble this whole thing, it should be a nice progressive push in and then a little snap at the end. It'll keep itself nice and aligned. We should be well clear of any other features that we have to worry about. And it should print in pretty much one go as 3 pieces. Like, that's one piece, easy. It doesn't want to be changing visibility of bodies. This is one piece, easy. And this is one piece, pretty easy. Even with these bump outs, that'll be trivial to print. So, yeah. Another successful, how long? Hour or so of streaming? Oh, hour and 10. That's not bad. Yeah, so I'm going to get that on the presses here in just a bit. if you're watching this later down the line, appreciate it. I'm kind of surprised you watched all the way to the end, because usually these are better live when people are giving design feedback and such. Yeah, I don't think I've got anything else to tack on. That constitutes an episode of Clark Modeling Random Things. Have a nice morning, midday, evening, night, or wherever you are, whatever time zone you're in. Yeah, take care. Thank you. Boink.